Hi, welcome to this demo. Today I will talk about the types of electricity, and for that purpose I will use two devices. This guy is called oscilloscope. It's used to scope the voltage with respect to time, and the upper device is called signal generator, and it is used to generate different waveform signals with different frequencies, with different amplitudes, with different shapes, with different offsets. I will explain these two devices when you need some knowledge about them. There is a button on the oscilloscope, power button, power button. You have to click it to open the oscilloscope. You have to wait some few seconds, and there is a power button here for the signal generator. You have to click it to open it, and you have to click any of the buttons. Now it's working, and it's a good oscilloscope. It has a auto set button here. When you click it, it automatically sets its adjustments and show you the signal. Here you see a square wave, and it oscillates between 0 volts and 5 volts. The oscilloscope device has its test signal. It's a 1 kilohertz square wave signal here, and its frequency is 1 kilohertz. Its amplitude is 5 volts. It oscillates between 0 volt and 5 volts. And to make some adjustment or to control the oscilloscope, you can use this signal like this. And this is the probe of the oscilloscope. This oscilloscope have 4 probes, 4 inputs, 1, 2, 3, 4. You can show different 4 voltages with respect to time together or separately. You can connect the probe like this. It has a BNC connector, and of course it has 2 terminals. This terminal is for ground, and this is for the positive side of the signal. You have to connect this to the ground of the circuit, or ground of the negative terminal of the component, and this terminal should be connected to the positive terminal of the component, or the point that you wanna measure the voltage. So I connect the test output of the oscilloscope like this, and I will see the square wave generated by oscilloscope itself at UC. And the other device, again, it has a BNC connector. It's used to signal generate, and the outputs of the probe is like this. This is red, it's for positive terminal, and the black one is the negative terminal. And if I connect the outputs of these two devices, the output of the signal generator is connected to the input of the oscilloscope, I can see the signal generated by the signal generator. Again, I click auto set button. It sets itself automatically, and there is no signal on the second input. I'm closing it. Let me plug it out, the second input, and again click auto set button. Okay, now I can read the voltage. As you see, it's a sine wave, and there are some information scripts here. It shows it is the signal for channel 1, and it says peak to peak value is 200 millivolts, and the period is approximately 1 milliseconds. And channel 1 is adjusted for 50 millivolts per unit. This knob is used to change the value of 1 unit. It changes the meaning of 1 unit. For example, now 1 unit shows 100 millivolts, and now 1 unit shows 50 millivolts. And I can change. Oscilloscope is only used to show the signal. It does not affect the signal. And signal generator is used to generate the signal. I can change the properties of signal from signal generator. I can read all values from the oscilloscope. Let me change the amplitude of the signal. Now, as you see, it is adjusted 100 millivolts peak to peak, and 1 unit is blinking. If you adjust this knob, as you see, it's changing. And if you click these buttons, you can change the blinking units. Then when you change this knob, you will change the blinking unit, as you see. Let me make it 1 volt peak to peak, and again auto set the oscilloscope. And now I see a signal. It has peak to peak value of 2 volts. 1 unit shows 500 millivolts, and it has 4 units, as you see. It makes, here is 0 volt, here is 1 volt, here is -1. It's oscillating. It oscillates between -1 and +1. Here I can change the peak value of the signal. When I click the frequency button of the signal generator, I can change the frequency and see the signal on the oscilloscope, as you see. And I can change the offset value of the signal, as you see. I'm increasing, I am pumping the signal up, or make it drop. Now it's a pure AC. And click on this if you need a sine wave. If you click on this button, it will give a square wave. If you click on this button, it will generate a triangular wave, and this shape, sawtooth shape. And you can generate some noise using signal generator. And this shape is called an AC signal. Its mean value, its average value is 0, and it's oscillating between a positive and a negative value. And it has a frequency and a period. I will change the frequency now. As you see, it repeats itself within some period, within some time. And this adjustment knob is used to shift the signal. Actually, you are not shifting the signal, but you are shifting the screen. Now the signal repeats itself within 2 units, and I can look at here. It says 1 unit is 500 microseconds, so 2 units will be 1 millisecond. The period of this signal is 1 milliseconds. It means the frequency of this signal is 1 kilohertz, as it is written here. So I can show the frequency here, and I can calculate it on the oscilloscope too, and easily I can see the period of the signal. And now one vertical unit shows, here it is written 500 millivolts. So the peak value of this signal is 1 volt, positive peak, and the negative peak is minus 1 volt. And this is an AC signal. Let me show you a DC signal now. As you see, this is a battery. It's a DC voltage source. If I connect the cables of this battery on the oscilloscope, I see a DC signal. Now nothing is connected. As you see, the screen shows a horizontal line, 0 volts. And when I connect the battery to the oscilloscope and click auto set button, what I see is a line again. And how can I read the value? It's written here. It shows one vertical unit shows 5 volts, and it's approximately 1 unit plus 0.8 units. It's approximately 9 volts. And here there is a script. It shows mean is 8.19 volts. It's the actual value of mean of this signal. And using oscilloscope, you can easily measure other properties directly read by the aim of oscilloscope. Let me connect an AC signal to the oscilloscope again and click auto set. And I see a signal again. It's a 1 kHz signal, AC signal, sinusoidal wave. And there is a button here, measure button. When I click it, I see some properties. It says channel 1 peak to peak value is 2 volts. When I click on it, source is channel 1, type is peak to peak value is 2.06 volts. When I change the type, I can read other values of this signal from the oscilloscope. Let me click on it. Now it writes cycle RMS value, and as you see, the RMS value of this signal is 720 millivolts. I can change the type of value. The minimum peak of this signal is minus 1 volt. The maximum peak of this signal is 1 volt. Rise time is approximately 285 microseconds. Fall time is approximately the same. Positive width is 500 microseconds. Negative width is approximately the same. And as you see, I can read many properties of the signal directly or looking at the screen. Thanks.